Hello everyone. This is the last question that we are looking at now on the sections of quadratic equations. As you have noted that previously we mainly looked at much simpler examples just to get the concepts. Now I want to introduce the last concept and also try to type the sections. And now we'll be looking at this last problem, which I believe it'll kind of tie everything that we've learned together, and hopefully you'll grasp the concept that I'm currently trying to introduce. So now we'll be looking at the K method. A K method is basically a substitution method that is used in order to simplify, because as you currently can see that the expression that we have here is kind of a complicated expression. You can imagine when solving it, we would have to multiply by this and then do some manipulation and then start to factorize. That's quite a very tedious process, and sometimes you could be lost in the calculations. So the K method is basically there to kind of help simplify the calculations. The very first thing you need to look at, especially if you're attempting to use the K method, is try to, as you could see, that this is a complicated expression. You would try to look at what you could basically use as a substitution in the expression. For instance, when we are looking at this expression here, we can see that we have 3x squared plus x here, which is common here, 3x squared plus x, 3x squared plus x, right? So as a K substitution, so to say, I'll choose to use the K equals 3x squared plus x, right? So I'm choosing this because it's the most common in all the terms. And I want you to take note as to how choosing K equals this value actually simplifies the expression. I'll write this expression a bit neat here at the bottom. So 4, right, we said that's equal to K. So we'll put in K instead of 3x squared plus x. So this is K. And then we have plus 1, right, minus 10. And we have K there, so we'll substitute K minus 1, right, over K equals 7. So as you can see now that the expression has been much simplified, and it looks more appealing than it did when we were writing this expression. So now to simplify this, I'll multiply by K throughout. So here on this step, I'll multiply by K throughout. So if we multiply by K throughout, the expression that we will be left with is 4K squared plus 4K, right? So and then minus 10K plus 10 equals 7K. So I just multiply by K throughout. So if you attempt to, on your own expand on this step, you should get to the same expression as this. But you can see how the K method actually simplified this calculation to a much simpler one, because if we had to deal with that, that's rather more complicated than just substituting 3x squared plus x equals K equals 3x squared plus x. And then now I'll just write this now a bit neat. So we'll have 4K squared minus 13K plus 10 equals 0. You just have to do the maths here. You're going to put that on that side, simplify, and then we'll have this value, right? And then here, I just want us to recap on the method that we use for factorizing, right? how we factorize. How we would factorize, would write down first this. We said the first thing we look at this sign, and we said that if it's a positive sign, we look at the term in the middle, right? And whatever term is in the middle, we'll have to put that on both, because since that is negative, so we'll have negative on both sides. And then we said we will have to find the factors of the first and the last term, that when we add them, they have to give us 13. So here the factors are 1 and 4, 4 and 1, 2 and 2. That's for 4. And now the factors for 10 are 1, 10, 10, 1, 5, and 2, right? So we're gonna start here, right, and go step by step, there and there, right? So if we attempt on the first one, we're going to do a cross multiplication. We'll have 10 and then 4, right? So what we want to achieve minus 13. That's the middle term that we want to achieve. So we have 1 times 10 is 10, 4 times 1 it's 4. It won't give us that. And also if we try this right here, 1 times 1 it's 1, 4 times 10 it's 40, and this won't give us minus 13 if we, so we continue to the next one. 1 times 2, so we have 2, 4 times 5 is 20, right? So we see that this won't give us any the minus 13, right? I know this is quite tedious, but I'm just doing it in order to demonstrate to you and to emphasize the points we've done previously. Remember that this method is this example, it's strictly for emphasizing the previous point. So we've seen that by multiplying these factors throughout, it doesn't give us the minus 13 that we need. So we scratch out this, we move to the next. So we have to multiply this again with the rest of these ones. So we're going to try that out. So if we multiply 4 times 10, right? So we're going to move on. 4 times 10 is 40. 1 times 1, it won't give us that. And then we move on to this one. 4 times 1 is 4. 1 times 10 is 10, right? And this as well won't give us the value that we need. So we move on to 4 times 2, it's 8, and it's 1 times 5, it's 5. But remember, we said we want minus 13, and the signs that we need to be both. So if we say minus here, on this expression we'll get minus 13. So we see that the expressions that actually did work here is this and that, right? So if we write them a bit neat here, we will have 4, 1, right, and 5, 2. And I'm not sure if you remember that we said, okay, what we take as this will be the first bracket and this will be the second bracket, right? So we'll plug in here. So this is the first bracket, it's 4x 5. This is the second bracket, it's x 2, right? So do you see we're able to quickly, now it's factorized, and then if we try to solve this, right, we will say 4x minus 5 equals 0, and x minus 2 equals 0. So we will solve, sorry, it's not x, it's k instead, because we're using k here. And then when we solve this, we'll get k. If we solve this, we'll get k equals 5 over 4, and the other k, if we solve this, will be equal to 2. So we get two values of k, right? But remember what we defined as k. So we said when we started our problem, that k equals 3x squared plus x. And it's not the value of k that we're looking for. The problem specifically asked us to solve for x. And at this moment, we have what the value of k is. So now we'll just replace, now using k equals 5 over 4. We're using the first. Now we'll have 3x squared plus x, right, which is k, equals 5 over 4, right? And then on the other hand, if we use k equals 2, we will have 3x squared plus x equals 2, right? So I won't get to the details on how to factorize this. It should be easy. If you should remember this from previous calculations, I'll just write it a bit neat here. So we will have, so if we multiply by 4 throughout, we'll have 12x squared plus 4x minus 5, right, equals 0. And if we factor this, we'll have 6x plus 5. You need to go learn how to factor that using that example we used, equals 0. And then if we solve this, we'll get to x equal minus 5 over 6, or x equals a half. You should know how to do that. You'll set the first bracket to 0, set the second bracket to 0, and so forth. There's two values. So we'll do the same here. We'll have 3x squared plus x minus 2 equals 0. And then factorize 3x minus 2, x plus 1 equals 0. And then we'll solve for x equals 2 over 3, or x equals minus 1. You should be able to solve this because you'll set the first bracket equal to 0 and the second bracket equals to 0, and then you should solve for these two values. And now, do you see now the final solution will be x equals to minus 5 over 6, half, which are these x's, and also x equals 2 over 3, and minus 1. So x can be any of these values. And so we are done with this example. So with this example, you should have learned and a lot of concepts in terms of equation manipulation, and how the K method actually helps us in simplifying the equation. Yeah, and that's it for the video. In our next video, we will look at inequalities.